morning, my friends. You must be tired by now. We have been deriving derivatives, and you have to be patient. We will be doing it for another maybe 1 or 2 lectures. Then we will come back to a session which is our popular session, Man Ki Baat. We will summarize what we were doing so far. In the meantime, one of my TA has solved a problem on second order system. These things are done to make you habitual of solving some standard equations. Do not give too much weightage on that. Try to understand the result, because those we will be using in our future discussions. Right. So, if you recall, we had u derivative, we have alpha derivatives, and then alpha dot derivatives, then delta derivatives. We have completed up to this. Today we will be discussing about alpha dot derivative, right? What is this alpha dot and why it is important? Please understand, if this is the wing and if it sees an angle of attack alpha, theoretically speaking, for normal flight, a normal type of maneuver, the lift build-up is not instantaneous. It takes time for pressure distribution to happen, and then the lift gets activated. However, in this case of alpha dot derivative, we will assume that as soon as the wing sees or any component sees angle of attack, the alpha build-up or strictly speaking lift build-up is instantaneous. Okay. This is an assumption which is true for the type of motion we are talking about, but if there is a highly oscillatory motion, right, then this statement may not be very correct. However, for our case, for small perturbations, we will assume that lift build-up is instantaneous. Second thing, which you should also understand, as there is a lift over the wing, or as there is a pressure distribution over the wing which causes lift, you are aware that there will be wingtip vortices. Okay? Remember, because of pressure distribution or pressure differences from the between the lower and the top surface of the wing, and these vortices will induce a downwash at tail. So, what these vortices will do? These vortices will give downwash at tail. That means, if there were no such wingtip vortices, then suppose this alpha was 5 degree seen by the wing, then the tail also will see 5 degree. No downwash if it was like that. But because of this downwash, there will be a downward component of relative air velocity. So, this angle now with downwash it will be 5 degree minus epsilon, and epsilon is the downwash angle in degrees. This is 1. So, effectively the angle of attack at the tail changes. But there is another salient point which we need to understand. If I ask this question, who is responsible for this epsilon? We know that it is because of wingtip vortices. And if I take the distance between AC of the wing and let us say AC of the tail, this distance if I take, I say xh. So, whatever happening at the tail is because of something has happened at the wing at the time xh by v earlier. Is this part clear or not? Let us understand. Suppose I am analyzing the phenomena at time t, tth second. What will happen? At tth second, some wing tip vortices will be generated. They will travel, and it's a fair assumption to believe they travel with the speed v of the airplane, and it will take finite time, which is roughly distance by speed. So, after that time only this alpha of the tail will get modified. Okay. That means, if I am analyzing at time t, I should be careful when I take this epsilon. I should know that this epsilon is caused this much of time earlier, right? And that is why this alpha dot derivative becomes important, and we will now try to formulate it. And what are those derivatives? We will try to find out alpha, CL alpha dot, which is nothing but dCl by d alpha dot C by 2 U1, CD alpha dot, which is dCd B by d alpha dot C by 2 U1, and Cm alpha dot, which is dCm by d alpha dot C by 2 U1. By now, you know why we are putting alpha dot C by 2 U1, because alpha dot has a dimension. We want to operate in a non-dimensional quantity. So, alpha dot C by 2 U1 is a non-dimensional quantity. Right. With this understanding, let us see how do we model it. If I try to know what is delta epsilon, I can write it as minus d epsilon by d alpha into alpha dot into delta t. If you see this carefully, this is d epsilon by d alpha into delta alpha, which I am writing as d epsilon by d alpha into d alpha by dt into delta t, and this is nothing but alpha dot delta t. All these linear approximations helping us to write like this. Okay. Why this minus sign? Because you know downwash will actually change the angle of attack. Okay. Now, let us see. If I try to find out dFax by d alpha dot C by 2 U1, this will be nothing but minus CD alpha dot into Q bar into S. I hope you understand this, because we are writing Fax. Go back to our earlier lecture. This will be Fax will be Q bar S Cx. And Cx, so dFax by d alpha dot C by 2 U1 will be dCx by d alpha dot C by 2 U1 into Q bar S. And you know approximately Cx equal to minus CD. So, dCx by d alpha dot C by 2 U1 is nothing but minus dCd by d alpha dot C by 2 U1. That is how this CD alpha dot is coming here. Fortunately, for most of the conventional airplane, it is not a bad idea to assume that CD alpha dot is almost 0 or can be neglected. So, our life becomes simpler. Okay. So, this derivative dfx by d alpha dot c by 2 u1, we can put it to 0 for most of our conventional airplane. Now, comes to CL alpha dot. Let us see what is CL alpha dot. The moment I see CL, and since we are working on with x, y, z axis, so I will start with FAZ. FAZ will be equal to q bar S CZ, and dFAZ by d alpha dot c by 2 u1 would be equal to dCZ by d alpha dot c by 2 u1 into q1 into S. Why this q1? Because I know this has to be evaluated at steady state. At steady state, q becomes q1. What was the steady state? For our analysis, it is the cruise, right? So, whatever the cruise speed was there, the dynamic pressure corresponding to that cruise speed at a given altitude at cruise is q1. Right? So, these things are well known to you. And after this, what we do? We write it as Cz alpha dot q1 bar S. And now see what is delta CL tail. That will be minus CL alpha tail into delta epsilon. Remember, I told you because of wing tip vortices, the tail angle of attack will be reduced by epsilon. So, the moment it is reduced by epsilon, so there is a reduction in the lift at the tail. So, that is why this is minus sign minus CL alpha tail into delta epsilon. No issues? Now, this I can write as minus CL alpha tail, and for delta epsilon we have derived an expression. We can write it as d epsilon by d alpha into alpha dot into LT by U1 delta CLT. Correct? CL alpha tail into delta epsilon. Delta epsilon is nothing but, we call delta epsilon nothing but d epsilon by d alpha into delta alpha, which I can write as d epsilon by d alpha into d alpha by dt into delta t, and delta t you are assuming as LT by U1, although initially we took the distance from the AC of the wing to AC of the tail, but we are doing an approximation. This LT is distance between CG and AC of the tail, and since CG of the airplane and AC of the wing are fairly close, so this approximation is also not bad. Okay. Remember, whenever you talk about CL due to alpha dot in terms of whole aircraft, this is at the tail. For the whole aircraft, you know, CL has to be defined as lift by half rho v square S respect to free stream. Okay. So, what will happen? The lift at the tail because of delta CLT will be half rho v square at tail S tail into delta CLT. Correct? Half rho v square at tail. Right? But when I try to talk about CL based on the whole aircraft, the contribution of tail, I have to non-dimensionalize this with respect to free stream dynamic pressure and wing area. So, this will become half rho v square tail into S tail delta CLT divided by half rho v square free stream into S wing. Correct? So, this is CL because of tail. Now, from here what we do is, if I write CL because of tail, which is non-dimensionalized in the standard form, we write half rho v square tail, then S tail delta CL tail by half rho v squared free stream, which is standard, into S of wing, and I substitute the expression for delta CLT from here, then I can write CL tail as CL alpha tail to d epsilon by d alpha into alpha dot into LT by U1 into neta t into S tail by SW. You may be wondering where this minus sign has gone, right? Please understand the expression of delta epsilon had a minus sign here, which I missed it here, the minus sign here. So, there is a minus sign here, your reduction, and that is how the minus sign got absorbed. Clear? This delta epsilon, if you see earlier I had just shown that, is minus d epsilon by d alpha into delta alpha, which is minus d epsilon by d alpha into alpha dot into LT by U1, and this minus sign and this minus sign get cancelled, and you get an expression like this. Now, please understand this CLT is due to alpha dot. Okay? That is very important. And we were working in terms of dfz, dfaz, this will not be x, this is fz by d alpha dot. So, we are looking for dz alpha dot or cz alpha dot to be more precise, and which is nothing but dcz by d alpha dot c by 2 u1. So, we have to work in terms of cz alpha dot, but we know that cz alpha dot is approximately CL alpha dot. So, this will be equal, this will be used, and I can differentiate this to get dCl by d alpha dot c by 2 u1 as CL alpha tail into d epsilon by d alpha into LT 2 by C into neta T ST by SW. Let me check. If I take a derivative with respect to alpha dot C by 2 U1, in this case, CL alpha tail will be this, d epsilon by OK, LT will be there, and that is, if I quickly check CL alpha tail into d epsilon by d alpha, then alpha dot LT by U1 neta T ST by SW divided by alpha dot C by 2 U1. This is nothing but CL alpha dot, because linear I can just divide. So, I see that this man goes off, 2 goes to numerator, U1 gets cancelled. So, I have LT by C neta, same thing. You see here, 2 comes here, LT by C is here, neta T ST by SW. Fantastic. Right? It is so nasty, but once you get a correct result, you start loving it. Now, once I know this is CL alpha dot, my aim is to find CZ alpha dot. So, I will write CZ alpha dot, which is equal to dCZ by d alpha dot C by 2 U1, which will be equal to just minus CL alpha dot. So, minus CL alpha tail into d epsilon by d alpha into 2 into LT by C neta T S tail by SW. Very good expression. This is fine. Now, it's imperative that from here, if you see this CL alpha dot, which is nothing but minus CZ alpha dot, that will be CL alpha T d epsilon by d alpha into 2 into LT by C bar into neta T to ST by SW. You see the minus sign is no more here because CZ alpha dot is minus CL alpha dot, right? And let us see how to compute this. CL alpha tail, we know, once we know tail. D epsilon by d alpha for low speed, this can be by CL alpha wing by pi aspect ratio E, or you can get this value through internal testing. LT you know, neta T you know, ratio of dynamic pressure. So, everything is known. So, at the design stage, you know the value of CL alpha dot. That is very important. Similarly, if I want to find out CM alpha dot, which is dCm by d alpha dot C by 2 U1, you could see who is causing CM alpha dot? CM alpha dot is coming because of CL alpha dot. It is a force in non-dimensional sense, it is a moment in non-dimensional sense. So, I have to just multiply this with the moment arm. So, I will write this is CL alpha tail d epsilon by d alpha. So, 2 I put here LT by C neta T ST by SW into LT by C. And we have to put a minus sign here. You can easily see from here that if multiply by LT by C and take appropriate sign, so CM alpha dot will be minus 2 CL alpha T d epsilon by d alpha LT by C neta T ST LT by SW. And you should also understand this is nothing but tail volume ratio VH. So, as a designer, you know how to find out the value of CM alpha dot, and that is minus 2 CL alpha tail, which you know, d epsilon by d alpha you know, and rest of the parameters you know. Right. Why this sign is negative? That question has to be answered, because we have agreed that whatever we are doing when we are trying to calculate this alpha dot derivative in a downward lag approach, that something has happened at time LT by V earlier. That means, at that time the tail had a larger angle of attack, right, corresponding to that time. So, that larger angle of attack will give a nose down moment or pitch down moment. So, this is minus sign. Are you clear with it? This is the tail and this is the wing. All these things what you are deriving, we are saying whatever happening here in terms of shading vortices, it takes time LT by U1 to reach here. That means, if I am analyzing at time t, that means those influence has not reached here. So, that means this angle is more than what would have been. So, that additional force will give a nose down moment, nose down pitching moment. So, this minus sign we have to put here, correct. So, we have now done CM alpha dot, CL alpha dot, and typically you will find the CM alpha dot value for most of the low speed airplane around 20 to 30% of CMQ derivative. Okay, right.